Hey everyone, it's Luke Lindgren from HAP Period 1, and I'm going to show you a few shenanigans you can pull on your TI-89 calculator. Let's get started. So first we're going to graph slope fields. To access slope fields, open up Varlink and hit S. Scroll down until you see slopes, then hit enter. Simply close the parenthesis. Now, unlike functions on the TI-89, programs usually do not require any general input. Instead, they will bring you up to their own screen. Now I'm going to type in a simple function with respect to x. This is because if I try using y, the system will blow up with a whole bunch of different errors and bring you to its source code, which I don't think you want to manipulate. When you're done typing in whatever function you want, hit enter. As you can see, it's going to graph the slope field on the standard graphing plane. Now, the nice thing about this is if I were to go into my y equals and graph whatever function, I could actually see if it matches the slope field or not. As this takes a while to graph every point, I'm just going to stop it right now, and we can move on to graphing different kinds of functions, primarily polar and parametric. First, I'm going to show you how to graph parametric functions, and then we'll move on to polar. Now the TI-89 has native support. Click Mode, and then when you see Graph, this should be what it automatically pops up to. Hit the side arrow key on the numpad. Now on the screen you'll see this box show up. Simply scroll down one, or hit the 2 button and then hit Enter. Hit Enter again to save your settings. Now under y equals, you will see that it asks you for x of t and y of t. For this example, I'm going to set my x of t as t, and my y of t as 1 over t. Hit enter. Now, xt of 1 and yt of 1 are both function 1. This is important to remember, because if you try graphing xt of 1 with yt of 2, stuff goes really bad. Now, I'm going to show you the graph. As you may or may not be able to see, let me readjust this. There is the parametric function for x of t equals t and y of t equals 1 over t. Let's move on to polar. Now, you might have noticed when I was in mode that polar is simply right below parametric. I can use the same process to graph a polar function. However, as you may know, polar functions don't have an x and a y of t component. Rather, they have an r of theta, where r is the radius and theta, well, is theta. Now, the TI-89, currently I have found no way to graph more than 2 pi. So if I were to have theta, which how you get theta is by hitting the second key, then plus to bring up the character pad, then hit 1, and then hit 9. Yeah, I know, a lot of buttons. It will just give me a single spiral. As you will remember, exponential growth is simply the principal times e to some value r, and then t. The reason why I'm not using t is because it's asking me for y1 of x. I'm going to hit enter. The logarithmic function to show the same equation would be the carrying capacity, in this case theoretically 100, divided by 1 plus carrying capacity minus the initial population size divided by the initial population size times e to the negative r t. Making sure all my parentheses are closed up, and of course I'm missing one or added one somewhere. Hit enter, and that looks right. Now I'm going to hit my graphing button, and the TI-89 will graph the exponential first. Then it will graph the logarithmic. Now I'm going to show you something really cool that your TI-89 can use. Now this won't necessarily happen in our current calculus class, however this will be something that will happen in Calc 3. So this is just a little glimpse, I should say, into it. This is a program called MultiInt. Remember to close the parentheses. And I'm going to hit enter. Now, this program can take a minute to start up. So I'm going to pause the video until it's done loading. And we're back. So I can set for single, double, or triple integrals. I'm just going to do a double integral. I'm going to do rectangular. I'm going to hit enter. I'm going to keep it in dy dx. And now it's asking me for an f of x comma y. I'm going to type in 1. Now my upper limit on y is going to be 2x. My lower limit on y is going to be x squared, squared, divided by 2. And then my upper limit is going to be 4, and my lower limit is going to be 0. I give you guys the exact same problem on the worksheet, so that way you guys know how to plug everything in. I'll supply links to additional problems on my worksheet if you want to continue to play around with it. Then hit enter, and it will give you the answer. Now vectors are the last thing I'm going to go over, because for all intents and purposes, they're just a very specific branch of parametric functions. Now there's 4 main kinds of vectors. There are position vectors, velocity vectors, acceleration vectors, and jerk vectors. Crosses between vectors, or a vector that is in all your x, y, and z direction, is usually called a composite vector. This is the actual direction your particle is going. Now, the TI-89, unfortunately, only has the ability to show you what a two-dimensional vector would look like. And that's what I put here. Now, in order to graph a vector, you're simply going to go underneath the parametric graphing window and graph that.